A liquid transfer vessel is a specialized component in a refrigeration system designed to move liquid refrigerant from the low side of the system back to the high side. There are two primary categories of liquid transfer vessels. The first category uses gravity as the impetus for liquid transfer. The second category uses a mechanical pump to move liquid from the transfer vessel back to the high side of the system. One of the unique components of the liquid transfer vessel is the three-way solenoid valve located at the top of the vessel. This solenoid valve connects the transfer vessel to both the high side and the low side of the system. The valve is activated by the solenoid that is interlocked with a float switch or level probe. During normal operation, the valve position connects the transfer vessel to the low side so that it can receive liquid from a larger low side vessel. When the solenoid is activated, the vessel becomes isolated from the low side as it comes equalized to the high side of the system.
What should an operator look for in a transfer vessel? That's a really good question to consider because there isn't a whole lot of moving parts when it comes to it. Yeah, there's a solenoid valve, and you might have there's gonna be a float switch, and you might have a sight glass. But one of the important components of the transfer vessel that hopefully exists would be the counter on how many times the vessel has been forced to transfer. So many don't think about this, but under an ideal situation, we shouldn't be having a lot of transfers. Our evaporators are causing the liquid refrigerant to evaporate, be returned to, let's say, a surge drum or accumulator, and that vapor is supplied back to the suction accumulator. There should be minimal liquid involved in that. So if maybe you're used to, in your system, getting one transfer per day, and then all of a sudden that number jumps from Thursday to Friday to 20 transfers a day, that's an indicator of a problem. So if you're an operator, that's something to look for. How many times has that vessel transferred? Now, sometimes there might be some sort of analog counter on that inside a control panel. Other times it might be an interlock with a PLC where you can see it on an HMI screen and you can see that counter go up. If you don't have that, it might be something worth looking into, integrating into your system so that you can see a problem before it becomes a big problem.
When a liquid transfer vessel is arranged to use gravity to move liquid, it will be located above the high pressure receiver and below the suction accumulator. During normal operation, or when the vessel is not transferring, the liquid that collects in the suction accumulator will drain by gravity to the transfer vessel. Once the liquid level reaches the height of the float switch or level probe set point, the three-way solenoid will be activated, causing the vessel to become subject to high pressure. Because the vessel is located above the high pressure receiver, this will allow liquid to drain by gravity from the transfer vessel into the high pressure receiver. The three-way solenoid valve will remain in this position until the liquid level drops below the set point or until a predetermined period of time has passed. Gravity transfer vessels are configured with two critical check valves. A check valve is a device that allows fluid to flow freely in one direction but automatically closes to prevent backflow in the opposite direction. The first check valve is located between the suction accumulator and the transfer vessel. This check valve prevents liquid from being pushed back into the suction accumulator when the three-way solenoid valve is energized. The second check valve is located between the transfer vessel and the high-pressure receiver. This check valve prevents high-pressure vapor from entering the vessel during normal operation when the transfer vessel is equalized with the suction accumulator.
All right, in this video, I want to give an overview of a gravity transfer vessel system. The first vessel here I want to point out is what's called our main suction accumulator. So this is a flooded refrigeration system. It has a bunch of surge drums up on the roof, and the wet suction coming back, that's vapor, but it might have liquid droplets in it, all terminate into this vessel before the dry vapor, pure vapor, is provided to the compressors. So this vessel is really just a last stop so that we can separate any liquid from the vapor. The liquid will go to the bottom of this vessel and then drain out the pipe here at the bottom, while the vapor is able to be taken off the top and feed the compressors. All right, so the liquid that settles at the bottom of this vessel is allowed to drain by gravity through this pipe, which then goes through this isolation valve. And what you can't see right here would be a check valve, okay? And a check valve, and then into the bottom of that pipe here, which then surges into our transfer vessel. So the movement of liquid from the suction accumulator to the transfer vessel is simply by gravity. Now, the transfer vessel is a unique vessel because it has this three-way solenoid valve at the top of the vessel. All right, and this allows this vessel to be subject to high pressure or low pressure, depending on the needs. During normal circumstances, the transfer vessel will be, this valve will be configured by its solenoid, so it's on the low pressure side, which allows the liquid to drain by gravity into the vessel through the check valve. Okay, now you'll notice this vessel also has a float column with two floats, this lower float here and a higher float here. Okay, when the level in the transfer vessel reaches the higher float position, it will cause that three-way solenoid valve to energize and putting the vessel under high pressure. So that three-way solenoid on one of its branches is connected to the high side of the system. Now, once that high pressure vapor enters the transfer vessel, it's gonna push the liquid in the transfer vessel out of the vessel and into our high pressure receiver. Remember, I told you there was a check valve in the line between the suction accumulator and the transfer vessel. That check valve is very important because without it, we would push that liquid back into the suction accumulator, which we don't want to do. So that prevents that from occurring. So liquid from the transfer vessel gets pushed out through this pipe and here into the high pressure receiver. Once again, this kind of a larger insulated piece of pipe has a check valve under it. And that's another very important check valve. It only allows flow into the vessel. Under normal conditions, when the transfer vessel's connected to the low side of the system, high pressure vapor isn't allowed to flow backwards because this check valve prevents that. So that provides you with a really good overview of how a gravity transfer system works.
If gravity-induced pressure is unavailable, it can be substituted with a mechanical pump. This is common when the suction accumulator and high-pressure receiver are mounted at the same grade. In this arrangement, the transfer vessel will also be at grade, but the arrangement will include a pump between the transfer vessel and the high-pressure receiver. During normal operation, or when the vessel is not transferring liquid that collects in the suction accumulator will still be allowed to drain by gravity into the transfer vessel because the suction accumulator is a much larger vessel. Once the liquid level reaches the height of the float switch or level probe set point, the three-way solenoid will be activated, causing the vessel to become subject to high pressure. However, because there is no elevation difference between the transfer vessel and the receiver, liquid movement will not occur without a pump. Therefore, the transfer pump will be activated by the three-way solenoid valve, causing liquid to be transferred into the high-pressure receiver. Pump transfer vessels are also configured with two critical check valves. The first check valve is located between the suction accumulator and the transfer vessel. This check valve prevents liquid from being pushed into the suction accumulator when the three-way solenoid valve is energized. The second check valve is located between the transfer pump and the high-pressure receiver. This check valve prevents high-pressure vapor from flowing backward through the pump and into the transfer vessel during normal operation when the vessel is equalized with the suction accumulator.
So let's talk about liquid transfer vessels. I've depicted here on the whiteboard a typical setup for a gravity transfer system. This is a pretty common approach, especially when there's a suction accumulator that's located above grade, off the ground. Often it will be a horizontal accumulator. In that case, we've got our wet suction from the system, from the evaporators going into this vessel. Since the world's not perfect, there's going to be some liquid droplets in that vessel. Liquid will fall to the bottom of the vessel and eventually would fill that vessel and be supplied out the dry suction pipe to our compressors if we don't deal with it in some way. So the common approach to deal with it is through a liquid transfer vessel. So how does this work? I'll tell you. Liquid will drain through a pipe at the bottom of the suction accumulator and through a check valve. Now, this is a very important check valve. There's actually two check valves depicted, and both of them are very important to the operation of the transfer vessel. But since the transfer vessel is located beneath the suction accumulator, liquid is allowed to flow by gravity through this check valve, through what I've depicted as a green pipe, and all the way to this check valve. Now, it can't go any past this check valve, and that's because this is our high pressure receiver. It's at a much higher pressure. We know liquid can only flow from a higher pressure to a lower pressure. Therefore, the low pressure liquid, even though we have gravity on our side, is not enough to overcome the high pressure pushing against that check valve. So that's where it'll stop. And then it will begin to fill this transfer vessel with liquid. So that's a good thing. We've got it out of our suction accumulator, and now it's in this transfer vessel. Now from here, you've seen I've depicted this with a single float switch. That's a common setup. Sometimes you'll see multiple, and we can talk about that. But this fills up until it reaches that float switch position. At the point in time that it reaches the float switch position, a very important thing happens, which is that it energizes this solenoid valve. And this is a very special solenoid valve. It's called a three-way solenoid valve. It has three connections to this valve. One connects vapor back to the low side of the system. The other connects to the high side of the system, usually the discharge of the compressors. And the third connection connects it to the transfer vessel. When we were draining, what I first talked about, it was connected to the low side. So in your mind's eye, you could even picture that all these green pipes that I depicted as green were blue, okay? It was all on the low side of the system. But once the level reaches this float switch position, it causes this solenoid valve to be energized. And now our high pressure vapor is introduced into this vessel. Okay, so what happened in that case is now this liquid transfer vessel just switched. It was on the low side of the system. Now it's on the high side of the system. So, and because the transfer vessel is located above the high pressure receiver, it can now flow by gravity into the high pressure receiver because both are at the same pressure. So the only difference is gravity, and that gravity is going to cause there to become flow. So all of the lines that are green during the transfer phase kind of become red, right? So we're now pushing that liquid, and it's going to flow this way into the vessel. It now can overcome that because these two vessels are at the same pressure, but gravity will cause that to overcome and flow through the check valve. Now, why doesn't it flow backwards to the low side? Well, that's where this check valve comes in. That prevents that flow. So during the transfer phase, this entire green, anything depicted as green becomes red in terms of my marker color choice until the transfer period ends. Now, in a single float arrangement like I've shown here, usually that would be on a timer. Maybe it's a 30-second transfer. Once that 30 seconds up, the three-way solenoid switches back to the low side of the system and everything returns as it was. There is an arrangement where you might see two float switches. The top float starts transfer, the bottom float stops transfer. That's another arrangement. So there's different ways to do that. Now, sometimes we don't have gravity to help us, and therefore we can't use the gravity transfer system. In that case, that's where we move and turn to a pump transfer system. Okay, a lot of similarities between these two systems, but there is one significant difference, and that is the addition of a liquid transfer pump. So we're adding a pump to this because we don't have gravity in our favor. Normally, this is employed when our suction accumulator is vertically mounted and ground mounted. So because it's mounted to the ground, we can't drain by gravity into our transfer vessel as easily. So these two vessels, under the normal conditions, the way the three-way solenoid works and everything is the same, these two vessels will be at the same level, okay? And once it reaches that float switch position, it will cause the three-way solenoid to be activated, subject the vessel to high pressure. It's on the high side of the system, but because it's at the same level, all vessels are at the same level, there's no transfer that will take place unless we employ a pump. So that's where the pump comes in. The pump is basically serving as the gravity component in this example. So that's an important distinction there. That's what all the pump is doing. It is moving that high pressure liquid into the vessel, overcoming that check valve, whatever pressure is required to open that check valve so that it flows in that direction. We still have two check valves so that we don't get reverse flow from the high side of the system back to the low side. Both types of systems are employed quite frequently. It just depends on how things are configured and whether we have gravity available to assist us.